Okay, so now we're talking about a different, I guess, structure for solving quadratics using square roots. In the last lesson, we talked about when x was the only thing being squared. Today, we're talking about when you have a quantity that's being squared. So it says that the basic form is either x plus or minus a number being squared equals a number. That's something like x plus 2 squared equals, say, 5. So the first thing you need to do is you need to get it into this most basic form where basically you're trying to isolate the squared portion. Sometimes you have a number here. When you're trying to do that, what you would have to do if you had a number there is you would need to divide by it. You never ever want to distribute that number. You can't pull it into something that's already being squared. It's not math and will always make things deeply wrong, okay? So once you have the squared part by itself, you would square root both sides. So what that accomplishes is then your squared disappears. And then here, you break it the way that you do normal square roots and like we did in the last lesson. So you'd have plus or minus, you attempt to break this, but it is 5, which doesn't evenly break or break at all because it's prime. So it'll stay like this. So then you need to finish solving for x, so you would subtract the 2. But where it goes is it will always go in front of the plus or minus sign. Even if there was a number here, like 7, 2, 12, whatever, you can't put them together because this is attached to the square root, so they need to remain completely separate terms, okay? So we'll always plant in front of the plus or minus. The only time that you can combine anything is when all of your square roots go away. And the first example that we're going to do is going to have that happen, so we'll talk about what that looks like, okay? So, looking at these examples, if you've got x plus 5 squared plus 3 equals 84. First thing you have to do is you have to isolate the squared thing. So to isolate the squared thing, you would have to move the 3 over. So you would subtract 3 from both sides. So then you've got x plus 5 squared is going to be 81. And then to get rid of the squared, you square root both sides. So then you've got x plus 5 equals plus or minus. Square root of 81 is just 9. Same thing if you are unaware that it's 9 because you don't know your perfect squares. You can break 81 and realize you have 2 sets of 3s and nothing else left and figure out that it is 9 that way. So this is different than the first thing that I talked about in that 5 and 9 can actually combine. Okay, -2 and the square root of 5 can't combine to make anything new. But 5 and 9 actually can. So what happens when that occurs is that you have to make 2 separate problems out of it. So what you do is you take x plus 5 and you set it equal to the positive version of 9. And you take x plus 5, you set it equal to the negative version of 9, and you solve it twice. So here you'll subtract 5, and x is 4. And here, when you subtract 5, you get -14. So this one has 2 distinct answers instead of one sort of plus or minus thing, which technically creates 2 answers, but they sort of work together in that they're conjugate pairs. Those are just 2 completely separate answers, okay? So we're gonna do 3 more and we're going to go across and not down because I want to do the easier one next. Not that the bottom one is super difficult, but it involves fractions, so I'm gonna do practice on a more basic one first. So same deal, you have to get the squared part by itself. So we're trying to get the x minus 3 by itself. You can't distribute the 2 because that would make everything horrible. Similarly, I didn't write this on the paper, but you can't distribute the squared. That's also not a thing that should ever happen. So you're trying to get this by itself. So you're gonna have to move over the 5 and move over the 2. you have to move the 5 first, so you would subtract it. So then you've got 2 times the quantity of x minus 3 squared is going to be 45 minus 5, which is 40. So then since we can't distribute the 2, but we know we have to get rid of it, you're going to divide both sides by 2. 40 divided by 2 is going to be 20. And then you would square root both sides. So then here you have x minus 3 equals plus or minus, and now you're going to break 20. So you got 2, 10, 2, 5, 5, 1. So you'd pull the 2, square root 5, because that's all by itself. And then you would have to move the 3. Okay, and this can't combine with this because this is attached to a root, so they need to stay separate. So again, the 3 is going to plant just in front of your plus or minus sign. And you need to leave them as 2 distinct parts, okay? All right, 2 more. Okay, so same thing, you need to get the squared part by itself. So we're going to add over the 1. Eight and 1 is going to be 9. Divide by 8. I want to give myself enough room to simplify the square root. That's why I'm all the way down here. Oh, yeah, okay. So then you end up with 9 over 8. So you will square root both sides. Okay, so then you got x plus 4 equals, because the square will go away. Start with the plus or minus, then we have to simplify this. Because it is now a fraction underneath a square root, you have to use your division skills and rationalize it. So to rationalize it, remember you are multiplying the top and the bottom by the square root of 8, because that's your bottom bit. So then you are looking at the square root of 72 over just 8. So then we need to break 72 down. So you got 2, 36, 2, 18, 2, 9, 3, 3, 3, 1. So you got 2 2s, 2 3s. So then you're going to pull a 6 square root 2, so that one is the thing that has no pairs, over 8. And then same thing, you can't reduce the 2 over 8 because the 2 is inside and the 8 is outside, but you can reduce the 6 over 8 in that they're both outside, so you should do that. 6 over 8 is going to reduce to be 3 over 4. So then you've got 3 square root 2 over 4. And now you got to move the 4 over. So when you subtract the 4, because we're solving for x, not x plus 4, remember it just plants in front of your plus or minus sign. Okay? Last one. So we've got 3 times x minus 2, quantity squared, plus 1 equals 16. All right, so like I said before, distributing in any way, shape, or form, awful and deeply wrong, okay? You need to get the x minus 2 by itself. So you'll subtract 1. 16 minus 1 is going to be 15. And then to get rid of this pesky number, you're going to divide by 3. So then you got x minus 2 squared equals 15 divided by 3 is 5. This is actually super similar to the first problem that we talked about. So you square root both sides. So then you've got x minus 2 equals, you got plus or minus. You could attempt to break 5, but 5 is already a prime number, so it doesn't simplify at all. It's going to stay the square root of 5. So then to finish solving, you'll add over the 2. Same thing, it can't combine with the square root of 5. Don't put it here. Make sure that you leave it in front of your plus or minus sign. And that would be the end of it.